Ladies and gentlemen, so in this video we are going to learn about wastewater management, and it will be focused on the wastewater management that can be done in humanitarian settings. You're in a camp, there may be refugees or internally displaced people, and you want to see how to manage wastewater. But first you have to appreciate what wastewater is, where it can be generated from, and we also look at the strategies that we can use to make sure that this wastewater does not pollute the environment and end up uh, causing problems to human health. So wastewater basically is that water that can be generated from those activities that we do, and it can be classified as domestic wastewater. It can be from specific sources like we are going to see, but it can also be as a result of agricultural practices. Then it can also originate from industrial processes. So domestically, we can find this wastewater. Uh, it can be from toilets, especially if in that humanitarian setting they are using toilets which are called power flush or even the flushing toilets. So you can get wastewater from that. And in that case, ultimately, it will be containing excreta in it, and it will be defined as sewage. So sewage, or which can be called black water, is that wastewater that will be carrying excreta in it in suspension, and it will therefore contain microbes. So you cannot reuse this water, or you cannot dispose it off without first dealing with it or treating it. Then the other domestic wastewater can be called sewage, and this sewage, which has also been termed as grey water, can originate from water distribution points. Could be taps, could be boreholes, could be the kitchens, the hand washing areas, and it often contains uh, uh, detergents, because you can imagine from these water distribution points, people can be washing their clothes. So it can also be containing grease and fats, especially if it is from the showers or bathrooms. And it will also be having microorganisms, but it might not be having uh, the microorganisms here might not be as intense as the ones in black water or the sewage. So from humanitarian interventions, or that specific water that we're talking about, you could have that sewage from laboratories, which may be used for surveillance to know whether these people who are in that humanitarian setting are having diseases. So they require water there. So you can imagine, if we are looking at this water that is coming from laboratories where they use different reagents, it might contain hazardous chemicals and microorganisms, because if they are they are dealing with people who could be having diseases, then that wastewater will also be having those microorganisms. Then the liquid residues from water treatment systems. So in humanitarian settings, especially those that have stabilized or are chronic in nature or have taken time, the camps that have lasted for some time, then they could put up some water treatment systems. Okay, so sometimes these water treatment systems also generate their wastewater. Okay, so in that case, it will also be classified as wastewater from humanitarian interventions. Then agricultural wastewater ultimately is from agricultural uh, activities, and it will contain nitrates from fertilizers, and pesticides also can also be in this agricultural wastewater. Then we also recognize that we have wastewater from industries. For example, in mining activities, they tend to use water for cleaning, So whenever it is disposed of, it will be industrial wastewater. And you can also acknowledge that this industrial wastewater will be having heavy metals, and other hazardous chemicals. So how do we then manage this wastewater? Okay. So we recognize that every situation where water is supplied, you will always have wastewater. Okay. When water is supplied for hand washing, after you using that water for washing your hands, where does the other water that you have used go? Okay. Where does this water that you have used to bathe go? Okay. The water that you have used for washing, where does it go? That wastewater. And how are you dealing with it so that it doesn't destroy the environment but also cause harm to the human health? Because there are some people who are going to leave it or dispose it off carelessly, and it will act as a breeding area for mosquitoes, which will now cause a lot of problems to human health by causing diseases like dengue fever, malaria, and others. So we should always look at how to remove and treat this wastewater so that we prevent stagnation and contamination of the water that we will use or drink, the one that we are calling potable wastewater, potable water. Sorry. So in humanitarian settings, uh, wastewater can be found at various points, and these include the water points where it can spill, for example, the taps or wells, then the user points in the kitchens, the showers or bathrooms, laboratory, like we had seen, washing areas where people wash clothes and other utensils. Then hand washing stations also generate this wastewater, but also power flush or flushing toilets can generate this wastewater, which will always contain that excreta and will be managed in a very rigorous manner. Then it can also, as we had seen, originate from those water treatment sites. For example, if it is used to clean those filters or in the process of backwashing to prevent the filters from being blocked, it will also be wastewater. So generally, we find that if we are going to say that we are managing wastewater, we need to make sure that all the stakeholders in that humanitarian setting are involved from the word go, from the planning to the implementation to the maintenance. Everyone should be involved, especially the one who is funding this project of wastewater management, or the people concerned with water, sanitation, and hygiene. They should be involved. Then the local authorities, and most importantly the beneficiaries, because these are the people that will be generating this wastewater. They are the people that are going to maintain these facilities which manage this wastewater. So everyone should be involved so as to have a very effective intervention of managing this wastewater. So a lot of these facilities that generate and dispose of wastewater will be provided, and they should be provided in a way that abides to the standards or the requirements of water and sanitation, but also adapt to the needs and habits, plus the culture of the beneficiaries. Okay, so if we are putting up any wastewater management or any wastewater collection uh, technique, does it rhyme with what uh, the needs of the beneficiaries are? Because you want to put up something that will be maintained, operated, that will be owned by these beneficiaries so that it can be sustainable. So the process of of this wastewater management majorly consists of four or three processes. It can You have to remove the wastewater, you have to do what we call potential pretreatment, and also you have to dispose it of or treat the wastewater. So removal, as the word suggests, is that is majorly the technique or the techniques involved in evacuating the wastewater to avoid stagnation or being in one point or standing in one point for long, to channel it for disposal or treatment. Okay, so you do not want wastewater to be in one place, stagnant, to be stagnant, to stand in one place or stay in one place for long, because then it can act as breeding places for those vectors that I had said, like mosquitoes. Okay, so the collection surface, ideally for this wastewater, should be gently sloped and cemented, because you do not want it to collapse. And when you put that gentle slope, then this collection becomes very easy. Okay, so the removal can also be done in three ways. You can use an open channel, which is always very cheap to put up, then a gravel drain, and then a pipe. And we look at each independently. Remember, we are still on removal. We want to remove this wastewater from where it has been generated. So you can use an open channel, you can use a gravel drain or a pipe. And in an open channel, which is the most simple and least costly, just put up a gentle slope. It is open, and it is ideal for you to cement that open channel. Okay, so if you dig that open channel, you should be able to create that gentle slope, and then should be cemented. And or if you cannot get cement, you can put stones or boulders to avoid it from collapsing. Okay, you want it to be at a level that does not have that does not go down, to prevent that gentle draining of this wastewater. Then in a gravel drain, we have a wide piece of plastic sheeting that can be placed or laid in that open channel. So instead of having the open channel alone, now you put in another plastic sheeting, so that it is not just open. Okay, so the problem with it is now unblocking, because at least for an open channel you can easily access it and unblock it in case there is need for that unblocking to be done, because we have seen that wastewater can come from places like bathrooms, kitchens. So this wastewater sometimes can contain fats, oils, and grease, and these materials, or these elements like grease or oil, have that tendency of attracting other things onto them. So when they attract these other things, this channel can be blocked. For an open channel, it is easy for you to unblock it, but in a gravel channel, in a gravel drain, it might be very hard for you to unblock it. So it means that if you have this gravel drain, you must make sure that these suspended or greasy materials are never used. So you have to use it in those generation points of wastewater which do not contain this grease. So you do not have to put it in places near the kitchen, in places near the bathrooms, because those ones will always create that blocking. Then in the pipe, which is the most effective way of removing all kinds of water, is used in a way that for it, why it is very costly sometimes, but the good thing with it, it can go for long distances, because remember, sometimes you want to treat this water, so you might want to treat it far away from where it is being generated. So then you have to use pipes. And when you use these pipes, you make sure that there is special care that is placed that is taken when uh, at those points where it crosses with roads where people are going to be passing, heavy vehicles and big animals, so that this pipe is not damaged, okay? And then the wastewater goes into the environment. Then also, ultimately, since it is always going to be blocked, you need manholes, okay? So these are like points where you can go in and access this pipe and check for those blockages, and if they are there, you rectify them, okay? So there should be those inspection chambers and manholes along these pipes so that we can maintain and unblock these, uh, these pipes. So step number two after you've removed this water is potential pretreatment. And this is done to remove solids or dissolved matter that could hamper the removal or the final disposal. And the techniques that are used here include the screening to remove floating and bulky objects. Okay. Then also you need a sand trap to separate the sand from soil. Sometimes you will also need a grease trap so as to eliminate oily and greasy material that can be uh, that can limit the way this water is disposed of. Okay, then a septic tank can be used when you want to eliminate fecal matter, especially in the sewage or the black water, that wastewater that comes from toilets, you know. Then sedimentation hole can be used to eliminate flux from the water treatment. So if you have this wastewater that has come, you have removed it from the site of generation, and then now you're taking it for disposal, you can put that sedimentation hole which enables uh, large solids to settle down, and then the effluent or the water that is not uh, containing those large solids to continue for further treatment or disposal. Then the third stage is basically disposing it all. So sometimes you do not want to reuse this wastewater, you just want to dispose it off, okay? But before you dispose it off, like we have seen, you have to do some kind of management. But in other times, like we are going to see, you want to reuse this wastewater. You have generated it, yes, it is coming from the kitchen, it is coming from the bathrooms, but you now want to reuse it for maybe irrigation, for maybe rearing fish. So for that wastewater to be used, it has to be treated. But if you do not want to treat it now after it has gone, it has undergone that potential pretreatment, which was the second stage, you now dispose it off. And how do you dispose it off? You dispose it off in a way that that enables it to be kind of treated, so that even when you dispose it off, it doesn't cause a lot of damage to the or any damage to the human or environmental health. So in this case, there are different techniques, and the choice of the system of disposal depends on the type and quantity of wastewater. So in humanitarian settings, the methods ideally should be very affordable, because remember, the resources are limited, but also it should be as durable as possible. So we prefer to use natural methods when we are disposing of this wastewater. And in this case, you want to dispose this wastewater in a way that promotes infiltration in maybe soil, and this soil that causes this that is going to handle this final wastewater should also be containing some element of microorganisms that are going to break down this the organic matter in this wastewater. So it utilizes this final process is going, or the final disposal is going to utilize the natural capacity of the soil to fix particles present in water by filtration, and then purify the water by the process of biological decomposition. Like I said, this soil where you're disposing of this wastewater should contain some microorganisms that are going to break down the organic matter uh, in this wastewater, so that it doesn't cause environmental and human health problems. Okay, so this biological decomposition has a way of dealing with that organic matter, but also the chemicals that can be in the wastewater. Okay, so if the wastewater is not going to be reused, so you can just dispose it of in the soil, and this soil should always, in most cases, not. It should also be in a way that uh, it is not so sandy or so clay, because if it is so clay, then its infiltration rate might be hard. If it is so sandy, it will let in the water very quickly, and that filtration and that biological decomposition might not take place. Okay, so we need something like loam soil, which can enable this infiltration to take place, and the biological processes also take place at the same time. So if you want to reuse the wastewater, then you have to treat it. Okay, or if this wastewater is highly contaminated, like the one from those toilets, it must be treated. Okay, so you do this to protect the human and environmental health, and it can be done in three phases: the primary treatment, the secondary treatment, and the tertiary treatment. So in primary treatment, you're looking at removing these organic solids through sedimentation, and then, so if you sediment, or if you let those solids settle at the bottom of this sedimentation tank that you could be using in wastewater treatment, then there will always be that water that is up, and then suspended material that can be floating, and these can be removed by skimming. So after all this, 50 to 70% of those total suspended solids and 65% of oil and waste can be removed at this phase. Okay, so this is the phase that can be used when you want to irrigate crops that are not going to be consumed by humans. Okay, so if you're going to irrigate crops, or if you're going to use this wastewater for irrigation of crops that are not consumed by humans, like flowers and the others, you do not want to overtreat. Okay, it is unnecessary. So you can only apply this primary treatment, and then you do irrigation. But if you want to to go on and use this wastewater for irrigation of crops that can be consumed by humans, then you have to go on and treat this wastewater. So after primary treatment, you subject it to secondary treatment, and in secondary treatment, we are utilizing these aerobic microorganisms, or those microorganisms that need oxygen to do this biological decomposition of the organic matter that is being contained in this wastewater. Okay, so it is a combination of biological treatment process and then primary sedimentation that will remove most of these suspended solids, and then some heavy metals present in the raw wastewater. Then in tertiary treatment, after you've now removed those uh, the organic matter and some heavy metals, and then the suspended solids, you do now focus on removing those specific wastewater constituents. So you can use activated sludge or sludge that contains some other microorganisms, and it will be focusing on removing nitrogen and phosphorus. For example, if you have generated your wastewater from agricultural processes and you want to reuse it for irrigation, sometimes you might not need these nitrogen and phosphorus, so you have to remove them using that activated sludge. So generally in practice, after you've done secondary wastewater treatment that involved those microorganisms decomposing the organic matter and dealing with those suspended solids after sedimentation, then it is always followed by the processes like coagulation to bring together those suspended solids that could have persisted. Then you can also again do sedimentation to settle down those solids that have resulted from the coagulation, because coagulation brings together the suspended solids, all those solids that are not dissolved in the water but are continuously uh, moving around it, the water. So by bringing them together in coagulation, the sedimentation will do the work of settling them down on the floor of that sedimentation tank. Then after that, this water will go into the filtration tank, which will separate those solids from the water. After this water has been separated from these solids, then you will now disinfect it. Okay, so disinfection, which is always almost uh, the last process of treating any wastewater or any water per se, is to get rid of now those microorganisms. Okay, because in disinfection you're focusing at killing any other microorganism that could be in the water. The water is now almost clear, but it could be having those microorganisms, the organisms that you can't even see with your naked eye. So how do you deal with them? You now use disinfection. Since we are dealing with humanitarian settings, disinfection using ultraviolet radiation or ozone might not be very applicable. It might not be feasible because it is a bit expensive. Okay, so we tend to normally use the, the 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 disinfection of chlorine, where we utilize chlorine to to deal with these microorganisms that could be persisting in this wastewater that we want to reuse in maybe irrigation of crops that human beings can eat. Okay, so the chlorine itself has some rules for it to be very effective in disinfecting or removal or killing these microorganisms in this wastewater. There should be some optimal pH, because we know that when pH increases, then chlorine might not be working very well. Okay, so as pH goes up, it might affect the bactericidal or the killing effect of this chlorine towards the microorganisms. So you do not want it to be so high. It should be optimal or maintained around 7.5, right there. Okay. Then the contact time also is very important, and should be looked at with reference to the wastewater that you are dealing with. Is it wastewater from the toilets? Is it wastewater from the bathroom? Is it wastewater from the kitchen? So that you know how much time is going to be spent on chlorination of such water. Then the organic content is also determined from where the wastewater is coming from. Okay. Then the effluent temperature. We know that with increased temperature, then the chlorine will also be decomposed. It will be degrading, or it will be breaking down and it will not be exerting its required effect. So you have to maintain optimal temperature so that chlorine can work very well to disinfect this water. So advanced wastewater treatment, or that wastewater treatment that aims at producing this water that will be used for irrigation of crops that are going to be fed on by human beings, might even take as long as 2 hours of contact time with chlorine, okay, or 120 minutes of chlorine being fed into that system so as to have purer water that can be used for this irrigation of crops that are going to be fed on by human beings. So, in conclusion, we recognize that wastewater management is very important in humanitarian settings, but requires rigorous planning and involvement of all stakeholders so that it can be done in a way that protects the environment, it protects the human being or the human health, and all this is done when the wastewater is effectively collected, treated, and disposed of in a correct manner. So that is it for wastewater management. Thank you so much for joining me today, and I wish you a good day.